Okay, this is going to be a problem about rounding a flat curve. Rounding a flat curve. And what is the question that we want to answer? We want to know what is the maximum velocity. What is the maximum velocity at which, what is the maximum velocity at which you can take the curve, the flat curve, without sliding. So that's the question you want to answer. What is the maximum velocity at which you can take the curve without sliding? And let's see, what do we have here? So we have a car going in circles. Oops. Okay, let's make it a better one here. So we have something like that. And we have our radius right here. So the radius would be this one right here. And okay, this would be the center. And this is the radius. And the car is going to be like a little particle. I'll put it right here. So this is going to be, this little car is going to be represented by this point here. This is the car. This is the car. And you can represent the car by a little particle. And the particle is going in circles. And it's moving with constant velocity. Let's say velocity is going to be constant. Velocity is going to be constant. I'm going to put it over here because I'm going to need this space right here. So I'm going to say that the velocity is going to be constant. And how can you solve this problem? Well, you have you're going to use the second law of Newton. And you're going to have equation 1, which is the summation of the forces in the x direction is going to be the mass acceleration in the x direction. Equation 2, which is the summation of the forces in the y direction, is going to be equal to the mass acceleration in the y direction. And you can use a third equation, which is going to be the friction is going to be the coefficient of static friction times the normal force. So we're going to use these equations. Another one is that the centripetal acceleration is going to be v to the square over r. So we're going to use all these equations to solve this problem. So let's do a body diagram right here. Let's do our body diagram right here. And what do we have? This is going to be the x direction. It's going to be the x direction right here. This is going to be the y direction. And we have some forces. Okay, we have a friction force that comes this way. Let's call it friction force. And then we have a normal force that comes this way. And then we have the weight, which is going to be mg. And we got 3 forces acting on the particle, which is the little car going in circles on a flat surface. This is a surface. Remember that all this is like on a table or something. So all this is on a surface, and it's going on circles there. So let's see. So in the x direction here, we have some forces acting there, which is the friction is going to be equal to the mass acceleration in the x direction, but that's going to be equal to the mass v to the square over r, because the acceleration is centripetal. So we got this one right here. And let's go to the second equation here, and we can say that the forces on the y direction are going to be N minus mg, and that's going to be equal to 0 because there's no acceleration in the y direction. So N is going to be equal to mg, and we can plug it right here. So the friction is going to be mu s times N, but N is mg, so this is going to be mg. So the friction is going to be mu s times mg. So we got our friction, and we go back and plug it over here in this equation right here. We can plug it right there. So we have that mu s mg is going to be equal to the mass velocity to the square over r. So what can we do here? We can get rid of the masses. You can cancel the masses. And mu sg is equal to v to the square over r. And you multiply everything by r here. So mu sgr is equal to v to the square. And mu sgr square root is equal to the velocity, and that's the maximum velocity that you can take. It's the maximum velocity that you can achieve without sliding. So they give us data. Mu s is going to be 0.2. G, of course, is 9.8 meters per second square. And the radius is going to be 30 meters. So we plug all that data. So it's going to be 0.2 times 9.8 meters over second square times the radius, which is 30 meters. And then we get the square root of all that. So the maximum velocity at which you can take the curve without sliding is going to be 58.8. Square root of that times the square root of meters to the square over seconds to the square. And that's going to be 7.67 meters per second. So that's the maximum velocity at which you can take the curve, a flat curve, without sliding. And there you go. You have another problem in which you have involved the second law of Newton for a particle that's moving in circles, and in which you have to account for the centripetal acceleration. And we'll do more problems next time. Thank you. Bye.